which is going to increase contractility of this muscle, making it a harder contraction under more pressure, if that makes sense. Okay? Wait a minute. Pulmonary trunk, coronary arteries. If that's what's got to take place, what has now happened in my pulmonary trunk and my coronary arteries? If my going to the aorta systemic has increased, pressure has increased, contractility has increased, all right? Well, what's happening on my pulmonary side? Yes. I can't have two different, right? I can't have the, well, if you do things, it's going to go bad. But you need to have both working, all right? So we're matching volumes, okay? Which means now, what's happened to volume, the times it's going to pump, and pressure on the right side. If it's increased on the left, it's increased on the right, which means I'm increasing it to the blood flow in the lungs. Because at the same time, the other stuff is taking place, what has happened to my breathing rate? It's increased. Why?
Keep up with the blood flow and oxygen.
Keep up with the blood flow, because I need oxygen, because I got to get it to the tissues that are active. And in the case of sympathetic, it's getting me ready to fight or flee, which means I'm getting a lot of blood flow to my skeletal muscle, okay? Decreasing it to my digestive system, all right? And increasing it with like nervous system, okay? So I'm increasing it. What about my coronary? I'm increasing it. Because remember, when the heart relaxes, blood flow to the coronary increases. If I have now increased everything else, if I've increased the blood flow, if I've increased my heart rate, if I have increased the contractility, well, what does the actual muscle of the heart do? Working harder. And therefore, we meet the demand. Things go wrong when the heart doesn't meet the demand. Just saying. Now, parasympathetic. All right, everybody just calm down. Because that's what the sympathetic does. It's like, calm down. Vagus. Everybody remember the vagus nerve, okay? Pretty much don't have an organ it doesn't touch, okay? Now, once again, pre, post, all right? For the parasympathetic fibers, they go through that vagus nerve to that cardiac plexus, mingle with my sympathetics, and continue to cardiac nerves of the heart. Now, this time, the sympathetic fibers, they synapse in little neurons on my epicardial surface. Where would that be?
Outside.
Epi is which part? Inner, middle, outer. Outer. On the heart wall. They terminate, SA, AV nodes, meaning, calm down, slow down, don't work so hard. Then once again, what we do, it calms down, heart rate slows, blood volume slows, blood pressure lowers, breathing rate lowers, and hopefully goes back to normal. Can you think of any everyday situations that this heart function needs to adapt? Sleeping, waking up. Now, I know it's a good idea that when you wake up from bed, not to just jump up and start going, right? How to get up. Okay, I'm really good at that. Okay, I'm really good at them. All right, to get it going. Because your body has been at rest, the heart's been at rest, blood flow, believe it or not, has been in different areas than if you're sitting or standing or walking. All right, you need to make sure it recalibrates.
Sometimes we get lightheaded the first like get up out of bed.
Do it all?
Is that like we kind of like sometimes we get lightheaded like jumping up straight up?
Sure. I get lightheaded going from sitting to standing when I'm old.
What about when you're eating?
Or the side of blood pressures from like where you go from sitting to standing and you get really dizzy and kind of like fall back down.
Do you happen to know why that happens?
Your body can't.
You're going to learn why in the next chapter. And you're going to be like, oh.
Take all the like.
It's also the reason most heart attacks occur in the morning. Yeah. So it's a good idea. After this chapter, and after the next chapter, you're going to say, whoa, I need to pay a little more attention to this because it is really cool. So now that we have this effect, okay, note that I'm trying to point out it doesn't control. It can affect the function of the heart. I've also changed my terminology now to it being the function of the heart, okay? And just like we would have muscle tone, for example, in the skeletal muscles, this innervation by the parasympathetic and sympathetic help the heart maintain its homeostasis, that normal rate of activity, but at the same time help us to meet demands that are placed upon it. People who exercise regularly have trained it, and their heart adapts to when it needs more blood flow and a stronger contraction. As we're sitting here now in class, we don't need the increased blood flow or the strong contraction. Okay? So that is what happens with the nervous system. Doesn't control it, only affects it. Now, one of the things that I keep mentioning, the electricity, okay? We know that it's electrical because we test it, the EKG. And I'll probably forever call it EKG. ECG just doesn't sound right to me. But anyway, ECG, EKG, the electrical events produce that cycle of the contraction and relaxation. Systole, contraction, diastole, relaxation. It creates our cardiac rhythm. Any of y'all checked your heart rate since Tuesday? No? Okay. Now, when the heartbeat is getting triggered by my SA node, meaning my heart is working like it's supposed to, okay? As long as my SA node is functioning, I'm in sinus rhythm. Okay? That's my norm.
So the opposition of that would be if you're on like a machine that keeps it pumping. Okay.
Yeah, SA node's not working if it's doing that. If my SA node is working and everything's good to go, sinus rhythm. Anything else, and it can happen. It can most definitely happen. It's called an ectopic focus. If the beating of your heart is now controlled, say for example, by the AV node, it's an ectopic focus. That one is the most common, and it's termed nodal rhythm. It affects the function of the heart because under the norm, the SA node, you should be probably between 65, 75 beats per minute. If you have to depend on the AV node setting the pace, you've almost cut it in half. Why is that a problem?
Because then if you need to go into fight or flight, you're not going to have the ability to go as strong.
If you're depending on the AV node and it does go into fight or flight, chances are you're going to have a heart attack.
Well, hold on. Before we go into that, what would make the SA node stop working?
Lots of things. Could be age, could be just a genetic condition. It could be a situation where you're coming into having some heart problems. Because see, remember, the SA node is really modified cells, okay? And if something goes wrong with that, it's not going to fire correctly. So there are lots of things that could cause the SA node to not work properly. Tends to be seen in more like if you've been pretty much healthy and throughout life and everything normal, might be something that comes along as you age. It could happen in people who might have some congenital disorders. It could be something that is a defect from genetics. Does it happen with people who do the drug use? Okay, it could come from the overuse of drugs and so forth. So there's lots of things that could affect
But I
it.
thought that the SA node is what then triggered the AV node. So how do you skip that step?
We will have, even though the nervous system doesn't control the heart rate, remember, it's still innervated by sympathetic fibers. And see, the autonomic nervous system has the ability to pick up on if the heart is beating correctly. And let's say that the body needs more oxygen, the sympathetic division could actually affect it to beat faster. Okay, so the body would still be picking up on, like say if the SA node wasn't working, we had dropped down to 40 to 50 beats per minute. This means I am now not getting the proper